those tutorial video sessions. In this video, we are going to talk about hybridization in the nitrogen atoms. If you have been following me, then you know that in the previous two videos, we talked about what hybridization is. Then we talked about sp3 hybridization, sp2 hybridization, and sp hybridization. And we illustrated how that hybridization takes place in the carbon atom. Now, another element that is common in most organic compounds is nitrogen. So to just have a further appreciation and a further understanding of hybridization, we'll also look at how the three types of hybridization we discussed in the previous videos occur in the nitrogen atom. So the nitrogen atom itself has got an atomic number of 7, which means it has 7 electrons, and this is the electronic configuration of nitrogen. There is 1s2, 2s2, and then 2p with 3 electrons. So when we are trying to illustrate how hybridization occurs in the nitrogen atom, we start by showing the orbitals in order of increasing energy. So we have the 3p orbitals in our nitrogen atom, and they have 3 electrons. So we have 1 electron of a single spin in each subshell. Then we have the 2s orbital, which has 2 electrons of opposite spins, and we have the 1s orbital, which also has 2 electrons of opposite spins. So this is the ground state configuration, or this is the ground state atomic diagram of a nitrogen atom. Now, when energy is added to the nitrogen atom, it enters into an excited state. And in that excited state, electrons get shifted to higher energy levels. So, when showing the excited state of our nitrogen atom, we follow the Pauli exclusion principle, and we start by filling in electrons of a single spin, and those are only 5 electrons. Then we bring in electrons that have an opposite spin. But because this atom is excited, the 2s orbital will only have a single electron, because the other electron from the 2s orbital has been shifted, or it has been raised to a higher rank, and we find it in the 2px orbital. So in this case, the electronic configuration of the excited state of nitrogen becomes 1s2, 2s1, and 2p4. So we can see that the 1 electron that was in the 2s orbital has been raised to a higher rank, which is the 2p orbital. Then sp3 hybridization takes place, which is a mixture of the s orbital and our 3p orbitals. So when this hybridization takes place, we are going to have our 1s orbital, which did not participate in the hybridization process. Then we are going to have our sp3 hybrid orbital, which is going to have 4 subshells. And in these 4 subshells, we are sharing 5 electrons. So first, we put in 4 electrons of an opposite spin. Then the 5th electron occupies the first sp3 subshell, and then this is the sp3 hybridized state of a nitrogen atom. So we'll find that in an sp3 hybridized nitrogen atom, there is one lone pair of electrons. There is one lone pair of electrons. And this is how we illustrate sp3 hybridization in a nitrogen atom. Now, when we talk about sp2 hybridization, and we want to illustrate how sp2 hybridization occurs in the nitrogen atom, we show the ground state. That's the ground state configuration of our nitrogen atom. Then the nitrogen atom becomes excited. And that is the excited state configuration of our nitrogen atom. Now, sp2 hybridization of a nitrogen atom means we are mixing one s orbital with two p orbitals. So when that sp2 hybridization occurs, the sp2 hybridization state of nitrogen looks like this. By the way, that's our 1s orbital, that's our 2s orbital, that's px, py, and pz. Likewise, that's our 1s, 2s, px, py, and pz. So now we have a mixture of the 2s orbital and 2p orbitals, and we're going to have an sp2 hybrid orbital which will have 3 subshells, and in those 3 subshells there is a total of 4 electrons being shared. So we'll have 1, 2, 3, and our 4th electron will be there. Then there is this unhybridized p orbital that remains there with a single electron. So we'll notice that an sp2 hybridized atom has a single non-hybridized p orbital. And this is an illustration of how sp2 hybridization occurs in our nitrogen atom. Then, when we look at sp hybridization, we start with our ground state with our 2 electrons. Then there's the 2s orbital with 2 electrons, and we have our 3 p orbitals, each orbital with a single electron, like that. Then we have the excited state configuration. We have our 1s orbital, we have our 2s orbital, and then we have our 3 p orbitals. And because this is an excited state, 1 electron has been raised to a higher energy level. Now, sp hybridization is a mixture of 1s orbital and 1p orbital. So this s orbital and that p orbital, they mix and they form an sp hybrid orbital. So in its sp hybridized state, nitrogen will be like that. We'll have our 1s orbital, which is not involved in hybridization. Then when the 2s orbital and this 2p orbital mix, they form an sp hybrid orbital which has 2 subshells, and among those 2 subshells we have 3 electrons being shared, and then there are these unhybridized p orbitals. these two unhybridized p orbitals, and each unhybridized p orbital has got a single electron. So from here you take note that an sp2 hybridized nitrogen has two non-hybridized p orbitals, and this is how we illustrate the three types of hybridizations in a nitrogen atom. Thank you for watching. Make sure you like this video and subscribe to my channel if you haven't subscribed yet, so that you stay in touch and you see my next video, which will talk about the three types of hybridization in an oxygen atom.